What lies beyond the sun's domain, and will we ever touch it? For as long as minds could lift themselves from the earth, this question has lingered like a flame against the dark. Ancient eyes looked upward and saw the night not as emptiness, but as a living canvas of gods, spirits, and destinations. To the Greeks, the stars were the fires of Olympus. To the Egyptians, the guiding lights of eternal journeys. In every culture, the heavens were not just distant, they were promises, unreachable yet beckoning. Centuries passed, and myth began to dissolve beneath the weight of reason. In the silence of Renaissance Europe, a Polish mathematician named Nicolaus Copernicus redrew the very stage of existence. The Earth was no longer the unmoving center. The planets, including our own, circled the sun, a revelation, both liberating and humbling. Humanity was no longer the anchor of creation, but a traveler in motion, part of a vast, unfolding system. By the dawn of the 20th century, imagination was no longer confined to parchment or scripture. Konstantin Tsiolkovsky, a quiet Russian schoolteacher, began to sketch the mathematics of rockets, whispering that Earth is the cradle of humanity, but one cannot remain in the cradle forever. In America, Robert Goddard gave fire to theory, launching the first liquid-fueled rockets into cold air. And later, Wernher von Braun took those fragile beginnings and built machines powerful enough to escape the pull of Earth itself. Then, in 1977, humanity's dreams found wings of metal and golden discs. Voyager 1 and 2, small, fragile craft, left the planets behind and began the longest journey of all, the journey out. They were not built to carry people, yet they carried something far greater: our questions, our voices, our hope that one day humanity itself might follow. The dream of leaving the solar system begins to fracture when confronted with its first great wall: distance. On Earth, distance is something we measure with ease. A road can be crossed in hours, an ocean in days, a globe in less than 2. Technology has shrunk the planet, pulling once distant continents into the span of a single flight. But space is not the Earth. Space dwarfs the scale of human intuition. And the gap between stars is not measured in miles or kilometers, but in light itself. Light year, the distance light travels in 1 year of relentless motion, nearly 10 trillion kilometers. It is a number that dissolves meaning, a unit invented to cope with magnitudes that break the limits of comprehension. And yet, even this measure, vast as it is, becomes small when applied to the galaxy. The nearest star system, Alpha Centauri, is just over 4 light-years away. On paper, it sounds close. 4 steps across the cosmic floor. But those steps are so large that no machine humanity has ever built can hope to cross them within a lifetime. Consider Voyager 1. Launched in 1977. For 46 years it has sailed outward, faster than any other spacecraft before it, racing. At more than 17 kilometers per second, it has already crossed the boundary of the heliosphere, where the solar wind gives way to the pressure of interstellar space. In the story of exploration, this is a triumph beyond measure humanity's. First emissary leaving the protective breath of its star, and yet, in terms of interstellar travel, Voyager has barely moved. At its current speed, it would take more than 70,000 years to reach Alpha Centauri. 70 millennia, longer than the span of recorded human history, longer than Homo sapiens has lived outside Africa. By the time Voyager drifts near another star, the languages spoken today will be forgotten. Continents will have shifted, perhaps even species will have risen and vanished. This is the scientific shock that haunts the dream of escape. The distances are not simply far. They're oppressive, crushing, a reminder of how small human lives are against the scale of the cosmos. For a creature whose lifespan is measured in decades, whose civilizations rise and fall in mere centuries, the journey to the stars feels not just daunting, but impossible. The numbers deepen the despair. Even if we built a spacecraft 10 times faster than Voyager, it would still take thousands of years to bridge the void. At 100 times its speed, centuries would still stretch before any destination could be reached. Like gravity itself, Without a new kind of physics, the stars remain locked away. It is here that Einstein enters, not as an engineer, but as the architect of the rules themselves. In 1905, his theory of special relativity revealed that the universe has a speed limit, the speed of light. No object with mass can ever reach it, for as speed increases, so too does energy demand. The closer one approaches light's velocity, the more infinite the cost becomes. It is as though the universe has strung an invisible barrier across the horizon, daring but forbidding us to cross. Relativity offers not only limits, but distortions. Time itself is not fixed, but elastic, stretching under motion. A ship traveling near the speed of light would experience minutes, while decades pass for those left behind. For the traveler, the stars might come closer, but for the world that launched them, the journey would still last millennia. This paradox, time dilation, offers no escape from distance. It only fractures experience. It's dividing the traveler from their home forever. To grasp the scale of this, imagine again Alpha Centauri, glowing faintly in the southern skies. At light speed, it is 4 years away, but at Voyager's pace it might as well be eternity. Serious. The brightest star in the night lies 8 light-years distant. Deneb, a beacon in the constellation Cygnus, burns from more than 2,600 light-years away. In the center of the Milky Way, the great heart of our galaxy, pulses from a distance of 26,000 light-years. In every direction, the gulf expands without mercy. The scientific shock is not only in the distances, but in the contrast between what we can see and what we can touch. Telescopes can bring the light of galaxies billions of years old to Earth. The James Webb Space Telescope can peer into the infancy of the cosmos itself, unraveling the faintest whispers of time. And yet, for all this vision, humanity remains trapped inside its own small neighborhood. We can see the stars, measure them, map them, but to reach them, this is a barrier more formidable than any mountain, more absolute than any ocean. The challenge becomes existential. If the laws of physics are unyielding, then interstellar travel may forever remain in the realm of dreams. Humanity may be bound to the solar system not by lack of will, but by the universe itself. And if that is true, then the solar system is not just our birthplace. It is our prison. This realization has provoked both awe and dread among scientists and philosophers. Oh, because the scale of the universe forces humility. Dread, because the horizon of possibility appears closed. For centuries, exploration has defined humanity's story. Oceans crossed, mountains climbed, skies conquered. Each frontier seemed impossible until it was achieved. But here, with the stars, the frontier is not merely distant. It is sealed by the laws of reality. And yet, even in the face of this immovable truth, the human mind resists surrender. For if the stars are unreachable, why then do we dream of them? Why do probes like Voyager, fragile and finite, still sail into the dark with messages of music and mathematics etched into their frames? To stand at the edge of comprehension, staring into distances that undo imagination, is to feel both trapped and free. Trapped by the body, but freed by the mind. The distances remind us that humanity is young in science, young in power, young in time. Voyager's 70,000-year journey is a warning, but also a measure of patience. The galaxy is not racing away. The challenge is not only in crossing the distance, but in enduring the scale of cosmic time itself. As Voyager drifts further, sending its faint signals back to Earth, it whispers this truth: we have left, but we have not arrived. We have begun the journey, but the destination is still beyond reckoning. The shock is not only in what we cannot do, but in how far we still must grow before we even attempt it. And so, the question lingers. Fragile and haunting, if the stars are too far, does that mean we must abandon them more? Does it mean that? Across centuries and millennia, humanity must reshape itself until the impossible becomes inevitable. If the solar system is a vast ocean, then humanity still lingers close to shore. The planets we know, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune are not the boundaries of our home, but only its innermost islands. Beyond them stretches a frontier more diffuse, more elusive, a wilderness of ice, dust, and invisible winds. To leave the solar system, one must first understand its true extent. The edge of the planetary realm is not the edge of the solar system. Beyond Neptune's orbit lies the Kuiper Belt, a sprawling disk of frozen bodies circling the sun like the scattered remnants of creation. Here dwell Pluto, Eris, Haumea, make dwarf planets with distant, glimmering paths. But even they are not the end. Beyond the Kuiper Belt lies the scattered disk, a domain of objects cast into eccentric orbits by the giant planets. Worlds whose paths can stretch for centuries before they swing back toward the sun and farther. Still lies the most mysterious frontier of all, the Oort cloud. The Oort cloud has never been seen directly. It is a sphere of icy bodies, perhaps trillions of them, surrounding the solar system like a halo. Its outermost edge may lie 100,000 astronomical units away, a distance so great that light itself would take more than a year to cross. It is here, in this distant reservoir, that the long-period comets are born. Their frozen surfaces preserved for billions of years until a chance encounter with gravity sends them tumbling inward toward the sun. The Oort cloud is the shoreline of the solar system, not a line drawn sharply in space, but a fading of influence, where the sun's gravity loses its grip to the tides of the galaxy. Yet even before one reaches the Oort cloud, there is another boundary, less visible, but more immediate. It is called the heliosphere, a bubble carved by the solar wind. From the sun's surface streams a constant outflow of charged particles racing outward in all directions. This solar wind inflates a vast sphere around our star, pushing against the thin plasma of interstellar space. Within it, the planet's orbit, shielded from much of the cosmic radiation beyond. Outside it, the interstellar medium flows unimpeded. The faint breath of distant stars drifting across the galaxy, the heliosphere is both sanctuary and prison. It protects Earth from the worst of cosmic rays, yet it also marks the line we must cross to reach the stars. For decades, its true shape and extent remained uncertain. Was it spherical, comet-like, or asymmetrical, sculpted by the galactic winds? To answer this, scientists turned to instruments both near and far. The Interstellar Boundary Explorer, or IBEX, launched in 2008, has mapped the edge of this bubble by detecting particles that bounce back from the boundary where the solar wind collides with interstellar plasma. Its data revealed an unexpected ribbon of energetic particles, a structure stretching across the sky whose cause is still debated. Some suggest it marks where the sun's magnetic field aligns with that of the galaxy. Others see in it a sign that the heliosphere is far more complex than once believed. Yet the most profound discoveries came not from orbiting satellites, but from Voyagers, small spacecraft launched in the late 1970s, never designed for such a task, yet destined to become humanity's first emissaries to the interstellar medium. Voyager 1, after decades of travel, crossed the heliopause in 2012, where the solar wind falters and the interstellar medium begins. Its instruments recorded a sudden shift. The charged particles of the sun gave way to the higher energy particles of the galaxy. Voyager 2 followed in 2018, confirming the transition. For the first time, humanity had touched the breath of other stars. But even here,
Out beyond the heliopause.
the solar system is not fully left behind.
The
The Oort cloud still waits, a silent, unseen frontier. It may take tens of thousands of years for Voyager to drift through its vast expanse. Only then will it truly escape the gravitational dominion of the sun. Until that moment, our spacecraft, and perhaps our species, remain tethered. The interstellar medium itself is no empty void. It is the thin plasma of the galaxy, enriched with atoms forged in ancient supernova. Hydrogen and helium dominate, but scattered within are traces of carbon, oxygen, iron materials that once formed the cores of stars, now drifting to seed new ones. This medium shapes and is shaped by magnetic fields, forming waves and filaments that span light years. For future travelers, it is both hazard and guide, a landscape of invisible storms, of radiation and dust, capable of damaging ships and altering trajectories. The mystery of this frontier is not only scientific, but philosophical. Where does the solar system end and the galaxy begin? Is the boundary the heliopause, where the sun's wind yields to others? Or is it the Oort cloud, the last fragile grasp of the sun's gravity? Perhaps the solar system has no edge at all, only a fading, a slow dissolving into the greater sea of the Milky Way. To map this shoreline is to confront the truth of our place. We're small creatures clinging to the warmth of a star, yet that star itself is not isolated. It is immersed in a galaxy that flows around it, its winds and fields brushing against others. To leave the solar system is not merely to escape the sun's reach, but to enter the ancient and ongoing dialogue of stars, the mingling of matter and energy across cosmic time. As Voyager drifts outward, its signal weakens, yet still it speaks. Each whisper carries data about the boundary it has crossed, about the particles that strike it, about the density of the medium through which it sails. In those faint signals lies the first cartography of interstellar space, a map not drawn on paper, but in the language of plasma waves and magnetic fields. The shoreline of the solar system is vast, elusive, and fragile. It cannot be crossed in a single step, but in layers, first the planets, then the belts of ice, then the fading bubble of the sun's wind, and finally the invisible cloud of comets scattered across eternity. Each layer is a frontier, each frontier, a reminder that leaving home is not a simple act, but a passage through thresholds older than life itself. The deeper humanity investigates, the more profound the challenge becomes. To cross this shoreline is not only to leave the solar system behind, but to confront the scale of the galaxy itself. But the ocean beyond stretches farther than thought can reach, and so the question sharpens. If we are only now learning where home ends, how far must we go before we can truly say we have left? Every discovery about the solar system's boundary, every map of its outer frontier, sharpens not only wonder, but dread. For the further humanity peers into the distance, the more impossible the journey appears. The dream of reaching another star collides with obstacles so immense they seem less like challenges and more like cosmic prohibitions. The first is distance, already staggering. At Voyager's speed 17 kilometers per second, the voyage to Alpha Centauri would take 70,000 years. But even this number hides deeper truths. To sustain such a journey requires more than speed. It demands survival over epochs. Longer than all of recorded civilization, requires endurance beyond imagination, not just of machines, but of species. Then comes time. Time is the invisible wall behind distance, shaping every calculation of travel. Human lives are measured in decades, civilizations in centuries, species in millions of years. The stars are too far for any measure that belongs to humanity. Even if a craft could be built to approach a tenth of light speed, its voyage would still stretch across half a human lifetime. Generations would be born, live, and die before arrival. For any crewed mission, the journey would not be an adventure, but an exile and abandonment of Earth, a farewell to everything known, and space itself conspires against the traveler. Radiation saturates the void, constant rain of high-energy particles from distant supernova and from the sun's own restless activity. Within the heliosphere, Earth is shielded. Beyond it, exposure rises relentlessly. For a human body, unprotected, the damage would be lethal in months. Cells would tear, DNA would unravel, the body itself would fail under the invisible assault. Only layers of shielding, thick, heavy, and costly to launch, could preserve fragile biology against this storm. Energy is the next barrier, perhaps the most insurmountable. Accelerate even a small craft to a fraction of light speed requires energy on a scale humanity has never commanded. Moving a single ton to 1/10 light speed would demand more energy than the world produces in a year. Scaling this to a vessel large enough for human colonists stretches the demand into impossibility. Even with nuclear power, even with fusion theoretical and unproven, the energy debt is overwhelming. And for every gain in propulsion, there is the equally daunting need to slow down at the journey's end. Otherwise, the ship would not arrive, but simply burn across a system and vanish into deeper void. It is here that the contrast between flesh and metal becomes undeniable. Machines like Voyager endure not because they are fast, but because they are indifferent. Radiation corrodes their circuits slowly, but it does not bring pain. Time passes, but they do not age. They drift through decades without longing, without need for food or air. For robots, the void is hostile, but survivable. For humans, it is lethal. This raises a truth that fiction often disguises. Interstellar colonization may not be a story of people, but of machines. Robots, probes, and artificial intelligence may become humanity's first true explorers of the stars. They may sail where no human body can survive, carrying our voice, our symbols, perhaps even the blueprints of our DNA. But if so, the dream changes. Humanity itself may never walk on distant worlds. Only its shadows, mechanical, digital, reconstructed, may cross the dark. And in this possibility lies fear. Fear of isolation. Fear that the solar system is not only our cradle, but our cage. That we may map it, explore it, even inhabit its moons and asteroids, but never step beyond into the galaxy itself. If so, then the stars will remain eternal. Lights in the sky, visible, inspiring, but forever unreachable. This is the paradox of progress. Step forward, each discovery, each probe sent outward, deepens the dream but sharpens the barrier. Telescopes reveal Earth-like planets circling. Nearby stars? The Kepler mission, TESS, and the James Webb Space Telescope have identified thousands of worlds, some lying in the habitable zones of their stars. The possibilities multiply. Oceans of water, atmospheres of oxygen, continents under alien skies. And yet, the closer these discoveries bring the idea of another Earth, the more unbearable the gulf becomes. We now know where to go, but we cannot go. The paradox continues with technology itself. Rockets grow larger, more powerful, but their limits remain the same. Chemical propulsion carried us to the moon, but it cannot carry us to the stars. Nuclear concepts promise more, but remain bound by engineering and fear. Antimatter, warp drives. Wormholes all shimmer at the edge of physics, speculative, uncertain, perhaps forbidden. Humanity's ingenuity climbs, yet the wall of relativity remains unmoved. Some dream of generation ships, its vast arcs carrying entire populations, traveling for centuries toward other stars. But here again, obstacles multiply. Would such ships sustain themselves? Could societies endure in isolation, cut off from Earth for hundreds of years? Would knowledge survive? Would culture persist? Or would such vessels become drifting tombs, monuments to ambition undone by time itself? Each idea leads not to resolution, but to further impossibility. Distance magnifies time. Time magnifies radiation. Radiation magnifies the need for shielding, which magnifies mass, which magnifies the need for energy. Every problem feeds the next, weaving a net that seems inescapable. It is not one obstacle humanity faces, but a chain, each link unbreakable, each link binding the dream tighter. And yet perhaps the greatest obstacle is not physics, but patience. Humanity thinks in terms of lifetimes, not millennia. It seeks goals achievable within decades, not ages. But the stars belong to ages. To reach them may require a patience greater than civilizations can sustain, a willingness to plant seeds that will not bloom for thousands of years. The question is whether humanity can extend its vision so far beyond itself, for whether the dream will wither under the weight of impossibility. For now, the solar system itself remains a vast frontier, rich with worlds, challenges, and resources. Moons like Europa and Enceladus hide oceans beneath ice. Titan offers rivers of methane and skies of haze. Mars lies barren but within reach. These are possible, tangible, near. But beyond them, the dark remains closed. The escalation of obstacles is not the death of the dream, but its haunting. It forces reflection on what it means to be human, fragile creatures of biology, clinging to a narrow band of warmth and air. It forces a reckoning with the possibility that humanity's destiny may be to remain here, to thrive in orbit around its star, but never to leave it. Yet even in this impossibility, there is wonder. For the very act of trying, of imagining, of sending fragile machines outward is itself a defiance of barriers. Voyager sails not to arrive, but to testify to prove that the dream exists, that the question is asked. Perhaps that is enough for now. The impossible road ahead may remain impassable for centuries, but it is in humanity's nature to walk toward it anyway, step by step, even if the horizon never grows closer. And so the paradox lingers. Each step reveals greater barriers, yet each barrier deepens the desire to cross. The stars wait, silent and indifferent. The road is impossible, but the dream persists. When confronted with the immensity of distance and the finality of Einstein's cosmic speed limit, humanity does not turn away. It imagines, it invents, it dares to ask whether the very laws of physics, which seem to cage it within the solar system, might also conceal the keys to escape. The history of interstellar speculation is a catalogue of audacity, bold designs, half-built prototypes, mathematical thought experiments. Each idea is a rebellion against inevitability, a refusal to accept isolation. The first rebellion came from nuclear fire. In the 1950s and 60s, engineers and physicists proposed a concept that bordered on the unthinkable: Project Orion. The plan was simple in theory, terrifying in execution. Spacecraft would ride a series of nuclear detonations, each explosion unleashed behind it, hammering it forward with shockwaves. A pusher, plate, armored and immense, would absorb the fury, converting devastation into thrust. In simulations, such a ship could accelerate to tens of thousands of kilometers per second, perhaps reaching nearby stars within centuries. Freeman Dyson, one of the architects of the idea, believed that with enough ambition, humanity could launch interstellar arcs. But the project was abandoned. The Partial Test Ban Treaty of 1963 outlawed nuclear explosions in space. With it, Orion faded into myth, a dream of riding fire that would never ignite. Fusion promised a subtler fire, the same process that powers the stars themselves. In the 1970s, the British Interplanetary Society unveiled Project Daedalus, an interstellar probe powered by nuclear fusion. Its engines, fueled by helium-3 harvested from gas giants, would burn in staged pulses, driving a vessel the size of a city at a tenth of light speed. The journey to Barnard's star, 6 light-years away, could be completed in 50 years. The design was detailed, rigorous, a fusion of engineering and imagination. Yet fusion itself remained elusive. On Earth, reactors still struggle to achieve net energy gain. The physics works, but the practicality lingers in the future. Daedalus, like Orion, remains a monument of paper, a blueprint for a world not yet. Built beyond fusion lies an even more intoxicating possibility: antimatter. When matter and antimatter meet, they annihilate in a flash of pure energy, releasing orders of magnitude more power than nuclear reactions. An antimatter engine, if built, could propel a ship to fractions of light speed with elegance unmatched by any other design. But antimatter is not fuel waiting to be mined, is the most expensive substance in existence. Particle accelerators can create it, but only in quantities so small they vanish with a whisper of energy. To build an engine would require kilograms of antimatter, each worth trillions of dollars, stored in magnetic traps with flawless precision. A single spark of error and the ship would obliterate itself. For now, antimatter propulsion remains not a project, but a dream of ultimate fire. If propulsion cannot break the chains of distance, perhaps geometry itself can. Einstein's general relativity describes space and time as a fabric capable of bending, stretching, and warping under the weight of mass and energy. In 1994, physicist Miguel Alcubierre asked a forbidden question. Could space-time itself be bent into a bubble that carried a ship faster than light, without the ship itself ever breaking relativity's law? His solution, elegant and startling, became known as the Alcubierre warp drive. By contracting space in front of a ship and expanding it behind, the bubble could, in theory, ride a wave of space-time, reaching other stars in days or weeks. The ship would not move faster than light relative to its bubble. Instead, the bubble itself would outrun the universe. But the mathematics came with a price. To create such a bubble would require exotic matter-negative energy densities, not known to exist, or if they do, existing only at quantum scales. Stephen Hawking warned that such manipulations might be unstable, collapsing under quantum fluctuations. Others suggested that even if a warp bubble could form, it might annihilate anything in its path. The idea remains both brilliant and haunting, tantalizing in equations. Forbidden in practice, wormholes carry the same allure. Described in the 1930s as Einstein-Rosen bridges, they are shortcuts through space-time, tunnels connecting distant points of the universe. In principle, they could allow instantaneous travel between stars. In practice, their stability requires the same exotic matter as the warp drive, and their entrances may collapse before anything can pass through. Kip Thorne, the Nobel-winning physicist who inspired the film Interstellar, explored their mathematics, showing that under the right conditions, they might exist. But even he acknowledged the obstacles. Wormholes may be permitted by relativity, but not by nature. At the edge of speculation lies an unsettling possibility. What if these dreams are not waiting to be unlocked, but are barred forever? What if relativity's speed limit is absolute, fusion forever impractical, antimatter forever scarce, warp drives forever unstable? If so, then the galaxy may be a prison without walls, a place where humanity can see the stars but never touch them. The irony is cruel. Physics, which revealed the vastness of the universe, may also forbid its conquest. And yet, even in this possibility, there is meaning. For these theories, even if impossible, have expanded the horizon of thought. They have forced humanity to ask questions no other species has ever asked. How does space-time bend? What fuels burn at the edge of physics? Can matter itself be annihilated for motion? These ideas are not wasted. They are paths into wonder, experiments of imagination that enlarge human understanding, even if no ship ever flies by their designs. For perhaps the act of speculation is itself a kind of journey. To imagine Orion's thunder, Daedalus's fusion, fire, antimatters, annihilation, or Alcubierre's warp is to step beyond the present, to test the boundaries of what might be possible. Humanity may never ride nuclear fire to the stars, but in dreaming of it, it has already left the cage of the ordinary. The chains remain, physics holds them firm.
Ow.
But the struggle against them is not futile, it is the definition of aspiration. Einstein himself once said that imagination is more important than knowledge, for knowledge is limited, but imagination encircles the world. In the struggle to break the chains of distance, humanity shows that it cannot be caged by despair. Perhaps. In the end, the greatest revelation is not whether these ships are built, but that they were imagined at all. For imagination is already motion, already escape, already the first spark of departure. The laws of physics may forbid the dream, but the dream, whispered in equations and blueprints, insists on being dreamed. And as long as it persists, the chains may feel less like prisons and more like challenges, daunting, eternal, but never enough to extinguish the fire. In the silence of the void, imagination reaches outward, straining against the immovable walls of physics. If the stars will not come closer, then humanity must find new tools to approach them. The dream of leaving the solar system has not been. Abandon it has transformed into experiments, projects, and fragile blueprints that might one day pierce the dark. Each attempt is small, imperfect, but each carries within it the seed of something larger. One of the boldest visions is called Breakthrough Starshot. It is not a rocket in the traditional sense, nor a ship of steel and fuel, but a sail of light. The idea is as audacious as it is simple. Build an ultra-thin, meter-wide sail, attach it to a gram-scale probe, and then strike it with a beam of lasers from Earth, each more powerful than any weapon ever conceived. Photons, massless yet relentless, would push the sail to a fraction of light speed. At 1/5 the speed of light, the probe could reach Alpha Centauri in just 20 years. For the first time, interstellar travel might occur within the span of a human lifetime. But even here, the barriers return. To accelerate the sail, the lasers must unleash a combined power of 100 gigawatts on infrastructure beyond anything humanity has built. The sail itself must withstand acceleration thousands of times stronger than Earth's gravity, while remaining stable under the scattering light of space. And even if it survives, the probe cannot stop. It will not orbit Alpha Centauri, but streak past at unimaginable speed, sending only a brief whisper of data before vanishing into deeper void. The dream is real, but fragile, perched on the edge of possibility. Other paths are more measured, but no less ambitious. Ion propulsion, already tested in missions like NASA's Dawn spacecraft, offers endurance rather than speed, using electric fields to accelerate charged particles. Ion drives produce only a whisper of thrust, but one that continues for years. Dawn, with a propulsion system no stronger than the weight of a sheet of paper in the hand, managed to orbit 2 different bodies in the asteroid belt, an achievement impossible for chemical rockets. If scaled and perfected, such engines might carry probes across the solar system with elegance, conserving fuel while slowly building momentum. Yet even they fall short of the leap to other stars. Beyond ion engines lies plasma propulsion, using magnetic fields to channel and expel superheated plasma at tremendous speeds. Experiments like the Vasmer engine promise higher thrust and greater efficiency, potentially cutting months from voyages to Mars. But still, the chasm of interstellar space mocks such advances. They extend humanity's reach, yes, but only from one planet to another, from one moon to the next. The gulf between stars remains untouched, and deeper still, in laboratories and accelerators lies the pursuit of fusion, the power that lights the stars themselves. If harnessed, fusion drives could transform interstellar travel. By fusing hydrogen isotopes, they could release energies millions of times greater than chemical reactions, propelling ships to speeds never before imagined. Concepts like the Daedalus and Icarus projects, designed by visionary engineers, visioned vast ships, kilometers in size, powered by fusion reactions, capable of reaching nearby stars within centuries. Yet fusion itself remains elusive. For decades, reactors on Earth have inched toward ignition, never quite achieving the balance of output greater than input. The stars perform it effortlessly. Humanity still struggles to contain it, if flesh cannot endure the journey. Perhaps intelligence itself can. Artificial intelligence and robotics may become the true pioneers of interstellar space. Unlike humans, machines require no air, no food, no warmth. They can endure radiation, drift for centuries, and awaken on command. Already, probes like Voyager, New Horizons, and Perseverance show the resilience of robotic explorers. Tomorrow's machines may be more than tools. They may be minds in their own right. Learning, adapting, deciding could become humanity's emissaries to other stars, carrying not only data, but purpose, evolving in the darkness long after their makers have vanished. The first interstellar voyagers may not be human, but human made a reflection of us, though not us. Guiding all these efforts is a question as old as the dream itself. Where should humanity go? The search for habitable exoplanets is not merely curiosity. It is compass. With telescopes like Kepler, TESS, and the James Webb Space Telescope, astronomers have revealed thousands of planets orbiting distant suns. Some lie in the habitable zone, where liquid water might flow. Some show atmospheres, clouds, even hints of chemistry that could signal life. Each new discovery sharpens the longing. There around a star 40 light-years away may lie an ocean glimmering under alien skies. There, circling a red dwarf, may lie a rocky world with air thick enough to breathe. The dream of departure is tethered to these possibilities, each exoplanet, a light in the dark beckoning. And yet the tools remain fragile. Breakthrough starshot remains theory, fusion remains incomplete, ion and plasma drives remain slow, artificial intelligence remains in its infancy. Humanity reaches outward with hands that tremble, tools that falter, technologies that gleam with promise but crumble under scale. The dream persists, but always at the horizon, retreating as each step is taken. Still, there is beauty in the attempt. To test ion propulsion is to stretch the patience of engines across years. To chase fusion is to mimic the stars themselves. To launch a light sail is to harness photons, the most ancient travelers of the universe. To search for exoplanets is to imagine other skies, other oceans, other possibilities for life. Each tool, imperfect as it is not only a machine but a declaration: humanity will not surrender to the void. Perhaps the first departure will not be a colony, but a whisperogram of metal and silicon racing across the abyss, carrying with it a fragment of human thought. Perhaps the first interstellar traveler will not be a man or woman, but a probe, small enough to rest in the palm of a hand, yet swift enough to outpace every ship before it. Perhaps the first human presence beyond the solar system will not be flesh, but code, and so the tools evolve, fragile and unfinished, yet luminous with possibility. Each carries humanity closer, not in distance, but in imagination. For the road to the stars is not only built in laboratories and workshops, but in minds that refuse to accept isolation. The universe may be vast, the barriers immense, but the search continues, searching for power, for endurance, for intelligence, for destinations. Searching, above all, for a way to leave. The stars remain silent, waiting. But with each sail designed, each plasma stream tested, each exoplanet revealed, the silence grows thinner. The question grows louder. If not now, then when? If not us, then who? What does it mean to leave? Is escape defined by distance or by meaning? For centuries, humanity has measured progress in journeys, across seas, across continents, into skies, into orbits.
Outward.
Each voyage outward has seemed like liberation from the confines of the last, but when the dream expands beyond the solar system, the question deepens. To leave the sun's domain, what does it truly signify? Is it survival, a desperate bid to endure beyond Earth's fragility? Or is it transcendence, an attempt to reach something larger than life, larger than history itself? The solar system is more than geography. It is sanctuary. Here, 8 planets in their moon's orbit, in fragile balance, bathed in the warmth of a single star. Earth, poised at just the right distance, cradles liquid oceans, air to breathe, soil to cultivate. To step outside this sphere is to abandon the only cradle humanity has ever known. The sun's warmth, constant and merciful, fades. With every astronomical unit traveled outward, beyond Neptune, the sunlight is pale, a dim lantern in an endless night. Beyond the heliosphere, even that comfort disappears, placed by a sky stripped of shelter, a darkness alive with radiation, silence, and cold. Humanity is fragile against this backdrop. Thin skin of atmosphere protects it from cosmic rays. A narrow band of temperature allows water to remain liquid. The human body itself is bound within a narrow corridor of survival. A breath of oxygen, a sip of water, a spark of warmth. Strip anyone away, and the flame extinguishes. Against the infinite ocean of interstellar space, the human organism appears absurdly delicate biological dust, clinging to the flicker of a star. And yet, this very fragility is what makes the dream of escape so profound, for it is not machines, not planets, not stars that long to journey, is minds housed in mortal forms. Daring to imagine the impossible, the paradox of space is stark, infinite emptiness stretches in every direction, devoid of air, warmth, or sound. To plunge into it is to seek not comfort, but exposure to the harshest wilderness in existence. And still, humanity longs to dive into this abyss. The yearning is not rational, It's not born of necessity, at least, not yet. It is something deeper, something woven into the pattern of being human. Perhaps it is the echo of evolution, of ancestors who once looked beyond forests, mountains, and oceans, who left the safety of the familiar for the unknown. Each departure was a risk, yet each defined the species itself. To leave the solar system may simply be the next echo of that same compulsion, the endless urge to step beyond the horizon, no matter the danger. Einstein, in his theory of relativity, revealed a universe of boundaries, no faster than light travel, no escape from spacetime's rules. Stephen Hawking spoke of black holes, of entropy, of limits woven into the very fabric of reality. Their voices remind us that the cosmos may never be conquered in the way humanity dreams. Light speed may remain an absolute. Wormholes may remain. Speculation, distances may always dwarf lifetimes. If so, then perhaps escape is not measured in where we go, but in what we attempt. The act of striving itself becomes the definition of transcendence, for in trying to leave, humanity transforms. Each probe launched beyond Earth expands understanding. Each telescope that reveals an exoplanet reshapes perspective. Each experiment, with propulsion systems, pushes imagination into new territory. To leave the solar system may not require a body to cross into interstellar space. Perhaps it only requires a mind to imagine it, a probe to symbolize it, a generation to begin it. The dream itself alters the trajectory of thought, bending human destiny toward the stars, even if the stars remain forever far. And what of survival? Earth itself is not eternal. The sun will burn for billions of years, but long before its death, it will swell. Oceans will boil, atmospheres will vanish. Asteroids, supervolcanoes, or the slow entropy of climate could erase civilization sooner still. To some, leaving the solar system is not transcendence, but insurance a way to scatter life, so it cannot be extinguished in one blow. Yet even this is paradox. For while escape may preserve, it also demands transformation. Human biology may not survive the crossing. To endure life may need to change into machine, into code, into something that can survive radiation, time, and the void. The survival of humanity may not look human at all. Still, there is a different survival to consider, not of bodies, but of meaning. Voyager carries golden records etched with music, greetings, and diagrams of our world. These fragile disks may outlast the species that made them. Even if humanity never colonizes the stars, its symbols already drift between them, testaments of thought, proof that on one small planet, minds once reached upward. Perhaps this is another form of leaving less physical, but no less real. The greatest journey may not be measured in kilometers or light years or centuries. It may be measured in thought itself. Every generation that imagines departure has already stretched the frontier of possibility. In imagining a road to the stars, humanity already reaches beyond its solar system. The dream itself is a voyage in inner expansion, as vast as any physical crossing. So the meaning of escape may be less about arrival and more about longing. Less about stars walked upon and more about minds stretched toward them. For as long as humanity dreams of leaving, it has already begun to leave. Each thought, each attempt, each fragile machine drifting outward is a step into the infinite. The solar system may hold humanity's bodies for millennia, but not its imagination, for imagination has already broken free. It travels now in stories, in equations, in machines of metal and golden disks, in beams of radio reaching outward faster than any ship. The dream is already there, stitched into the fabric of the galaxy itself. And perhaps this is the final paradox, that even if humanity never conquers the cosmos has already conquered humanity through wonder, through longing, through the endless pull of the stars. The night sky remains silent and vast. The stars wait, indifferent, yet eternal. Whether humanity ever walks among them may remain unanswered, but the act of asking, the act of reaching, the act of dreaming, that is already escape. For in dreaming of other suns, humanity has already left the solar system.